Okay, so our new topic is actually called bivariate data, which is on the front of your booklet. So bivariate data is when you generally have two lists of information, and the information from the two lists, it's all come from one source. So if you think about it, if I went around this class and collected your height and weight, so see how I got two pieces of information out from the individual, and then we would look at those two things and see if there's if there's some pattern between it. So I might say, when people's heights get bigger, does that make their weights get bigger or something like that? So we go to compare. So I might also compare things like, I might ask how many people in the family and how many holidays you go on. So you get two pieces of information. That's what bivariate data is. Okay, so at the start now, we're going to investigating the relationships between two numerical variables. So that's like when we're going to get two lists and the two pieces of data that we're collecting are numerical variables. So the one I said before, they were both numerical. Your weight is a number, yeah? And your height is also a number. So when you get the two things that you are looking at, they're called variables. So one is called the explanatory and one is called the response. So the explanatory one is used to explain or predict the value of the response variable. So for example, with your weight and your height, so with that one, explanatory one, we often also, you might want to write this too, it's known as the independent, and you might have heard that in science, the independent variable. So it's often the one that is not affected by the other, yeah? So you might say not affected by the other. So if you think about it, with our weight and our height, can your height change because of what you eat? No. Like say for example, it won't, will it? Your height is what you got to begin with, and it's not going to be changed, is it? So that one would be the explanatory. What happens to your weight could change, couldn't it? So if I'm a taller person, I most likely will get more weight about me, yeah? But just because I weigh 100 kilos, does that necessarily mean I'm tall? No, not really, yeah? So can you see your height is a little bit independent? So the response one, in your science, you know it as the dependent variable, and it's generally the one you're looking at. You want to see what happens. So when we're talking about height and weight, we probably wouldn't be looking at, there's not much we can do with people's height. They are what they are. But we will look at their weights and see what happens. So you often see too, when you graph these numerical ones, and we'll look at this later, your response variable goes on the y-axis and your explanatory variable goes on the x. So if you think about graphs, say I measured how many times you went to training and then your times that you got on a time trial. So we would be looking at your time trial. We want to see the response of that. So that would be the response. And how many times you went to training, that's probably the explanatory. All right, so let's go practice a few of these with the ones here. So identify the explanatory variable and the response variable in each of the following situation. The variable names are italicized, so they're in the cursive, sort of the slant thing. So if you look at the first one, we wish to investigate the relationship between age of a certain type of tree and its diameter. Can your age be affected by anything else? No. It's just going to be what it is, isn't it? So which one do you reckon that is? It's independent, so we call that one here explanatory, don't we? and the diameter, we're looking to see how fat the tree got, is your response. Good. Okay, let's do the next one. A study is made of the relationship between weight loss, so how much weight you lost, and the number of weeks a person is on a diet. So what do you think we would be looking at? What do you reckon we want to see what's happening in? What would I be investigating to see how much weight loss, yeah? So that one is probably our response, yeah? And the number of weeks that a person goes will be explanatory. So think of the response as what, if you're having a look at, you want to know what's happening there. So data is collected to investigate the relationship between age of a second-hand textbook and its selling price. So we already know, is age going to be affected? Just because it's cheap, does it necessarily mean it's old? No, like it doesn't matter. It won't affect it. So this one is explanatory, and we'd be having a look to see what the price is. So the price would be response variable. Second last one, the relationship between the number of hours of a gas heating system is used and the amount of gas used. So which one do you think is the explanatory? Which one is independent, or which one do you reckon you'd be looking at how much is being used? Number of hours is it going to be explanatory, yeah? And the amount used will be the response. So a good little way to know, you know when you do your graphs in science, isn't time often along your x-axis? You know when you do those graphs and stuff? So it's a good little indicator. Time is often explanatory or independent. Okay, so a study is made of the relationship between the number of runs a cricketer scores and the number of balls bowled to them. So what do you reckon you'd be looking at? What would we be looking at the response of? What do you look at when you look at cricketer? You generally look at their runs, don't you? Yeah? So that one would be, the runs would be the response, and the number of balls that they actually had bowled to them will be explanatory. All right.